My name is Greg. I'm with Johnson Controls, if you haven't met me already. I'm project manager for the installation of this project. So supposedly if you have any problems, you can call me. Everyone's kind of got my son. I do not have a business card, but I will put my number up on the board if you need to. So if you have a problem, again, and 732-259. There you go. Also, if you guys know, my assistant that's on site is Nick. He does all the startup, all the point-to-point. So if you need to know a location of something, you might know of a point on a sensor on a graphic, but you don't know where it is in the field, give us a call. So this way here we have smooth transition into plant operations when we do a turnover. All right, first thing I want to cover is what is the Metasys system in the field. So what we have is we have a couple of controllers. One is like the mother that has all the software in it. It's called an NAE. All right? That NAE has brains. It's all brains and holds software. And there's no points. No physical hard wires to it other than communication and power. So that's, you need to know that. So when you go onto a screen and you see, hey, I have 20 VAV boxes not reporting, the first place you want to troubleshoot is the NAE. Okay? So basically when you have a network riser, an NAE has 2 ports on it that can hold 99 devices each, or 5,000 points, point count. That's point count. So if you have a VFD and you're sucking in 30 points, you're not going to hit your 99 devices because your VFD is going to suck up a lot of data. So these are the things, that's what you can overload the NAE. So inside the chiller panels and the cooling tower panels, you have an NAE. The other panel we have is called the NCE. The difference between the NCE and the NAE, the NCE only has one communication loop going out to drive, so it cuts this out, but it still has this point count. So it has higher memory with less stuff going in. So the same thing would happen. If you have the chiller plant, the whole thing looks like question marks, or in this case, I believe it's a cooling tower, your NCE could be down. I know you've had some problems with it. You power them down, you power them up, but they all have UPSs on them, which should be, when you do a generator switchover, have enough power to last for the generator to kick on and power up the emergency circuits.
Sorry, how many NAEs we have?
In this building, well, on this project, you only have one new NAE and one new FAC, which I'm going to get to. Okay? As far as the chilled water system. So I'm getting through the hierarchy of your control panels, because these are the ones that control all the software, and then we're going to draw a network loop that shows you what you have downstream of those. Okay? And then the other one I was going to get to is an FAC. And the reason why we have an FAC, it looks like it has more point count. It has a total of 12 points that can go to it, and has the memory of an NCE and an NAE. So when we have a real heavy load, like a chiller plant, we want to have a lot of things hardwired for safeties, we use an FAC because it can hold a lot of software. So that's the important thing, is to know your main controllers, where the main controllers are, and later we're going to walk through the job site and show you these panels, where they are. Whoops. So those are your big panels here. So on a network diagram, you're going to have your computer, which is currently in the BMS room, your server, right? We're going to run communication cable to these main panels, which is usually a Cat5 and Cat 6. Right? So they're going to go here, they're going to hit through a network switch. There might be a network switch in here. So you have to know how your network is run. And eventually we're going to get a nice riser diagram and go through that. But it's important that you know these, because if the main controllers go down, you're going to get all question marks on your screen. That should be a target.
Hold on a second. Main controller, this is, we're talking, we have like a three of controllers. NAE, NCE, and FAC. Which is one of the three?
You have all of these on the job site right now.
No, I understand that. You say if we have that, all of that question marks, we will have down on this controller one of each one from that. Or
Everything downstream of this on that communication wire would be blank. So if this NAE is controlling the cooling tower, everything is going to be blank. The VFDs, the temperature sensors, everything is going to be blank. So don't look at the individual controllers downstream. You're going to look at the big guy, right? So when you have a large portion of a building going down, that's like, this helps you troubleshoot. So when you call me on the phone and you say, Greg, I got hundreds of question marks, I'm going to say, go to the NAE, go to the NC, go to the FAC. That's your number one thing. So you need to know that kind of hierarchy. Okay, so that's that. So that's important to know the hierarchy. And I always start there because everyone panics when the whole screen is blank, when it could just be one controller. When you go to the controllers, and when we have Nick on board, he'll explain to you the lights on each one of them. Is it communicating? Is it working correctly? They do have fault lights on them. So that's kind of that. Now what we're going to go through is, I'm going to change this. You saw how we had a network communication go to all, this is a mother controller, now we have baby controllers, which the baby controllers can be a FEC, right? A VMA, which we don't care about the chiller plant, but that's what controls a VAV box, and an IOM. So a FEC comes in various ranges, but that thing has 12 I/O input outputs, and we're going to go to I/O, what I/O means, right? And there are various types, and that's going to be on the loop from your NAE, NCE, and FAC. And like I said, you could theoretically put 99 on one loop, but again, point count matters. If you put a VFD on there, it's on the same loop, you're sucking up a lot of data. So chiller plant, put the chiller, we communicate to the chiller the same way. We tie the NCE in, that's another point, you might say, but it has a lot of points on there. So slowly you start filling up the memory and you get to that 5,000 number. So on the FEC, which we'll find, has got I/O points. You have 4 types of points that you should look on this graphic. It's an analog input, analog output, digital input, digital output. Okay, an analog input is a temperature sensor that'll keep changing. So if you have the cooling tower and you want to know what's the temperature, on a chart graph it would look like this. Keeps moving up, down, or in a different direction. And it's an input. Same thing with the output. That would be a valve that's going to keep modulating for an air handler to maintain temperature. In this case, it could be an output to a tower fan that says to speed up to maintain tower temperature. All right? A digital input is on-off. Okay, so when you have a tower fan that comes on, there's a thing called a current donut. That sends a signal that the tower's on. So it's either on or off. So that's important to know. This is on or off. And the same thing with a digital output. It's on or it's off. So we're commanding a pump to come on or a pump to come off. So those are the 4 points that you need to know. and they're hardwired. Now we have software points, which are set points. Set points are software points and timers. So in software, we have timers and set points. They're not a physical point, there's no wire to it, but it remains in software. So if you put the chilled water temperature set point at 44 degrees, there's no written rhyme or reason to it. That's what it is. It's hard-coded in the software. You can't change it. And a timer is a time delay. So when we get status of a pump, we can now turn on the fans, turn on the chiller. So when you look on the graphics, you'll see there's set points on one side and commands on the other. So set points are software, commands are all hardwired. You're going to turn items on and off. So I think we got that. So you guys understand that? That kind of yes or no? You have questions on it?
Yes, let me know. Just let me get this.
All right, so that, and like I said, some of these might be basic to someone, but I just want everyone to get up to speed before we get into the individual submittal. Because if you don't have that background, then this submittal doesn't really work well for you. All right, so if you have this submittal, it should look like this. If you have that handy, you want to get a copy of it? All right, and you look, and we start with the chilled water plant, and we start up at the top, you'll see that some things are grayed. The items that are grayed are what was existing before this project started. So we added another pump. So when you see PCHWP, that's primary chilled water pump. So primary chilled water pump 1 and 2 were existing, and we added number 3. And when you look at the box, the white boxes, that's hardwired. When you look at the gray box on PCWP number 3, the new pump, that's software. So the 2 gray parts are software, and the 3 white boxes would resemble hardwired points. Okay? So this is why the beginning of this was important, that you understand software and hardware. So the one that says PCHWP3-S, that is status. That is telling you that the pump is running. And we're going to go into a panel, I'll show you a current donut on how that current donut's working. The PCHW-3,
1 second, I'm sorry, this is that white boxes, it's a software points, right? Actually,
the white one is hardwired. It's a physical hardwire that goes.
No, that, wait a second, this one, 1, 2, 3.
They're hardwired.
This is hardwire.
And these are
this is
software.
this is true software.
Yes.
Right? And this is a hardwires, and this is, it's a set points. What's over there?
Well, the software is the set point. The actual wires, right, are, as I'm going to go over each individual one. The S stands for status. That tells you there's a current donut. It's a round device that looks like this. Let's see, rectangular. Okay, and it has a place for 2 wires to come in here. It has a hole in it. And what happens is the wire goes through here, okay, and creates a current. And when it creates a current, it closes this contact. And that contact tells us the pump is on or off. So you can get that information when you click on the VFD, but we find it's critical that there's certain ones that are hardwired. So if you lost communication to the drive, the wire gets cut. Remember how we had the NAE here? And then the wire comes here, and it could go to a VFD, and it can go to the next controller, an FEC. If this wire was cut, we still have hardwired points to that drive that you could still control the drive. That's the purpose of having some of them hardwired. So when you have a VFD, this is going on a little bit of a tangent. When you have a VFD, there's 3 methods of control, all right? One is auto via those 3 points. 2 is manual override from the front end, which you can then do. And 3 is manual going to the drive. And that stuff will be covered when we walk around in the field. But now I just want you to get this, because this is your Bible. You carry this around, you'll be able to walk around the plant and understand how the plant works, how to fix it, what parts to order. And I want to teach you how to read it. That's the important thing. Phil, you don't seem so happy. All right? So I wanted to teach you what that VFD is, what's hardware, and what's software. Now if you go to the chiller, you'll see there's the chiller's in the center of the screen right underneath the word system. We added a new chiller. So going from right, it says CH3-S. That's to start the chiller. CHEN is to enable the chiller.
N, right? Enable.
Yeah, enable. EN is enable. Okay? And then the O is the set point, where it says CH3SP-O is the set point. You can give the chiller a set point. And again, I'm going to stress that the lowest number the chiller set point should be is 44 degrees. I'm going to write it down. You have it. I'm going to find one that actually has... So chiller set point, catch, just to make sure you're awake. Chiller set point, oh wow, I forgot an N, cannot be less than 44.
Why is that?
Cannot, you can freeze the chiller out. All right, so 44 degrees, that's where you want to keep it. It'll hum, that's it. That's the point you want, right? I mean, if you guys want to come in and override it on a day that's cool and make it higher, you can do that too. You know, if you want to make it 48, 50, because don't forget, the air handlers downstream, they really want to discharge what we call discharge air temperature of 55 degrees, right? So if the outside air temperature is 60 something and you just need to knock it down a little bit, you really don't need 44. But that's, again, that's for another day. That's looking at plant efficiency. All right? So if you're going past the chiller, right, you have condenser, evap, and compressor. Then you see CHWFS. That's a flow switch. It's highlighted in yellow for a reason. That is hardwired internal to the chiller. So if your pump is not flowing enough water through the barrel, the chiller will not run. So that's an internal lockout. And when we go to the screen in the HMI screen and the chiller guy's with you, he's going to go through that.
What's numbers of flow of what we're looking to go through the chiller barrel?
I don't know what the minimum
Which one
is.
will stop it below that doesn't work, right?
Right. So what happens is, I'm not sure, and I'm going to say it might be 168 gallons per minute.
Every chiller is different.
Yeah, every chill is different.
By the manufacturer.
Right. So I think the minimum is 168 and the max is 386. Just using experience on that. I don't know that number, but save that question, write it down. The guy upstairs will be able to tell you right off the top of his head. His name is John. I'll introduce you to him. So then the next point is the chilled water temperature, discharge of the chiller.
CH3-CHWS-T.
T, right.
What is it?
T, it's for temperature.
Temperature.
So that's the temperature reading. It would be an analog input, and that's going to tell you what the temperature is
Is this a
discharging.
sensor or what is it?
Yeah, it's a temperature sensor. All right? And now I'm going through this, and you might write this down. You're going to find it redundant, but the answers are all on the page. The next one is a differential pressure monitor where it says CH3 CHW-F. So what we do is we take the differential pressure between the inlet and outlet, and we can do a calculation and tell you what the flow is. So the reason why it says F, it's a flow. But, and this is critical, and I think Mike and I, when we first met, started going over this. A differential pressure sensor works on 2 copper tubes. Again, when we walk through the field, I'll show you. You have the transmitter here, and the transmitter here just has a little tiny diaphragm in between. There's input here and an input on this side, and it's a copper tube. All right? And why I drew this is because here's your pipe here. Here's your pipe here. Oops, I drew it backwards, but there's your pipe there. So there's a pressure coming in and a pressure coming out. This measures the differential by making this diaphragm move back and forth. So when this diaphragm moves back and forth, it sends out a signal to us. And using that, we can calculate the flow inside the pipe. So that's what that is. This will tell you your gallons of flow. So when you bring up the question, what's your minimum? You can use that device, look on the screen, say I don't have my minimum. Or you can look at the valves. There's a valve. The valves are the number one thing. If valves are closed, the chiller is going to trip because it doesn't have enough flow. If this starts to decrease during operation, you can start looking at your strainers. Right? If you come in every day and the DP says 4.3 and the gallons per minute are X, if you keep running that chiller and this number starts to drop a little bit, there's either an issue with your pump, there's an issue with the strainer, impeller, something's clogged. It's a good maintenance point to check out. And it also, that'll keep your efficiency up and down in the plant. If you keep everything clean, your efficiency is going to be better. So that's that point. And again,
down, right? Differential pressure goes down. This might be a problem with the pump, strainer, something like that.
yes.
Okay.
And the next point there is your valve. It's an automatic valve. Pump will start to come on. Status of the pump comes on. Valve opens, and you should be good. Now, I know you wrote a lot of this stuff down, and the reason why, so you memorize everything. But on the top right-hand corner where it says Bill of Materials, you can look up at all of those points, and you could see what parts were ordered. So if something was broken, you can look at this submittal and say, hey, here's the part number, and I need another one. I mean, it's as if you're going to do the work yourself. If not, you could even say, hey, so-and-so, Greg, you got a service contract, this part failed, order it and then come out, versus come out here and figure out what's wrong and then say, I need the part. So that's why this submittal is kind of critical. It helps you in numerous ways of figuring out how the plant's working. All right, if you flip to the next page, you flip over, this is the sequence of operations. So you're having a problem with the plant. You hit the start button, and you're saying, well, it just doesn't work. Well, with this sequence of operations, you could say it went through the first step, the second step, and failed on the third step. So what's wrong? The valve didn't open, something didn't open. So it clearly will state what's supposed to happen. So I don't know if you want to read through all of that real quick, skim it and ask a question. What does certain words mean? You might not understand some of that. That's why differential pressure, I just spoke about that. Isolation valves, you should know of. I don't know, again, there's certain things that I don't know your experience in the plant. And we can go through it when we go through the graphic too. We're hopefully, I have the plant running now, but I wanted to call up there, which I can't, but I was going to shut the plant off and then we could even start it from a dead start. Someone can log in with their new password and hit the start button. And then if you have questions on that, but this is basically how that's going to work. All right? If you flip over to the next page, right, it's all kind of yellow, but this is all your I/O. And this is important because if you have a problem, this tells you where every single wire is landed. So when you have a control panel, this will tell you the UI is universal input.
I/O, I'm sorry. Would you remind me? This is
I/O is input output.
input output, right? Okay. Input output. Okay.
All right? So the UI is a universal input, which means it could be an analog input or a digital input. We program it in software. So there's some inputs that can only be digital or analog. It'll say it. Like it'll say BI, that's binary input. That's a digital input. It's on or off. So this thing will tell you where all the wires are landed. So when you go into a panel, the panel's laid out. You can go to the controller. You can look at, for instance, I'm going to say the chilled water return temperature for chiller number 2, right, should be the 4th one down. You'll see it says UI and it says input 4. So when you look, there'll be 2 wires. So it's going to an NCE. And when you go all the way across, it tells you the type of wire. 2 gauge, 2 wires, 22 gauge. I mean, I don't have a ruler to go all the way across. And then this will say temperature element. So I was saying here, I was just picking this one as my case scenario, the 4th one down,
Okay.
right? So that's the return temperature sensor. So then it'll tell you what type of wire we used. And TE stands for, when it says device, under field device, it says TE, that's temperature element. So that's a thermistor.
When we will be upstairs, just
You don't give the range.
you just step on this
Well,
one.
it says
wire.
it's a thermistor.
Would you show us exactly where is it on this one?
Yes.
On this particular one.
Yeah,
Okay.
sure. I'll have Nick do some of that.
Just to see where is it like physically, you know what is here, how to compare to find it over there.
Sure. Okay, so that I'm not going to go through every point, but if you have a question on any of the acronyms, there's an expanded ID on that, and it tells you pretty much what each point is. So if you have a problem where it says object name and you don't understand, like an SCH is secondary chilled water pump, but if you learn the acronyms, they are in the expanded ID. So if you looked over here, right, it has the word here. So this, when you look there, and now you can flip to this thing. So if you had a problem on where you were with the chilled water, you can look back on this page. So that's the total I/O count.
And this is saying which is a controller type.
Yes. So that's all there.
Binaries, hardwire?
Yes. Binary is the same as digital.
Is digital, is that?
Yes.
Alright.
No, analog is different. Analog is a moving point. Digital and binary are on off.
On off, yeah.
Okay? So like I said, this is the basics of understanding the system. So you know that. So you know what, when the digital point is there and where it lands on that wire and what the end devices are. And like I said, we'll give you, in the walkthrough, we'll give you an example of what the end devices are. We'll show you. All right, now the next page, if you look, there's a chiller plant layout, and it's the panel. All right, so that's what the panels are going to look like in the field, just like that. So this panel, for the chiller plant, when I told you there was an NCE, that's like, again, the brain's the controller. It's also got physical hardwired points to it. Underneath it is an IOM, which stands for Input-Output Module. So if we don't have enough point count on an NCE, we could put up to 7 IOMs on one panel. So that's added expansion for input-output. So the red wire that you see there is the communication cable going to each one. And not that the one on this panel says new panel, enclosure 2B, first floor pump room. That is the panel that's going to run the chilled water that's in the future going to serve the NRB. So there's pumps in the pump room, which we'll cover that when that's live running, and we'll get there.
How we can describe that? For example, this is the IOM, just to make for us more understandable what is it.
Okay,
I
so
see that here.
I'm trying to think of a good example. All right, if we have a controller that can only handle 20 points, I'm using that as a fictitious number, right? But we need 30. Okay, we can take this main controller here and call it address 1, and we can take an IOM, it's a baby, and call it address 2, and they will talk to one another. So we want to keep this all together because all the points here have to communicate one another. If I put an NCE here, right, and then I put another one here, their main controllers, they pull points. Then they're going to pull points, want to talk to the computer, come back here and pull again.
Is it
That's
like a
too
standard
slow.
of memory or something?
Exactly.
Similar to external hard drive. Something
Yes,
like that?
exactly. That's good analogy. So that's what it is. Because the way the system communicates, and the easiest way for that to be is a bus. I have a bus. The bus is coming by here. Okay? It's going to stop at a bus stop. It's going to drop people off and pick people up. So this is the controller with information, right? Now it's going to go to the next one. It's going to stop, pick up information, and drop off information. If I have to share information, what happens when the bus leaves here? It goes to every single controller, comes back here, and that's looking for information. So we try to limit the communication outside of the panel, right? The only thing we do is outside air temperature. That's one that every single thing needs because air handler is going to control based on outside air temperature, right? If it's 45 degrees out, we want more outside air. If it's 80 degrees out, we want less outside air. So we want to share that. But we want to minimize what we do when we share because that slows the whole network down. So we want to keep adding the IOMs on there so we don't have to go outside for information. So you finding this good so far? Phil, you just keep shaking your head. So that's the purpose of the IOMs. And it's, again, everything that's mounted inside the panel, right, relays and everything are in the bill of materials. So your IOMs are in there, your power supplies, your transformers, everything you need to rebuild the panel should be listed on the top right-hand corner. And again, there's UPSs in these panels, in which we'll have, demonstration how the UPS works. They have a battery in them, basically, and again, that's to make sure when your generator comes on, you're good. The following pages are individual wiring diagrams. So you could trace the panel out, trace the wires out. So you should be on central cooling plant ladder wiring diagram. So it'll show you the transformer, how many wires went from each device. So I don't know how familiar you are with the end devices, but we can go through that if need be. So that's the basics of the submittal. Again, you got the cooling tower layout panel, same thing for the cooling tower. And again, that's got an FEC on there with IOMs, and same thing, a bill of material. This page you're on shows you the wiring type. So when you look on this, it'll tell you the wiring. See panel wiring, and it'll tell you a detail. See where it says field device? Right here, it'll say wiring detail, and it has a number. Oh boy, these are the Savas copies. Yeah, you can use this one.
Yes, okay.
Oh yeah, there you are. So where it says field device and wiring and tubing, there'll be a detail number. That detail number reverts back to the page you were just looking at here. See how it says detail?
F701.
So you can go there, and if that detail was needed, it'll be there. So the intent is that this is your Bible. If you have questions on it, call me. You know, I'm here frequently. You know, I know you kind of keep some spare stock, like NAs, NCs. I thought you had a couple spare.
So I guess what out of stock are you gonna provide?
That, I'm not sure. I have to look at the spec on that. So,
Yeah, look, this one, for example, F701, right?
right?
And that F701 is not listed here.
Well, that doesn't mean we necessarily use that detail. You know what I'm trying to say? If we didn't have that, you know, here's a binary input, which you usually have all over. So 303 you should have.
303, yes, I saw somewhere.
Yeah. So, you know, just, it depends on what was wired to that panel. That detail sheet, this sheet here is a generic sheet that we throw in on everyone.
We also don't have.
Let me see.
301 we have. 303 we don't.
Yeah, I can't even read these. Oh, this is a, yeah. So you might not necessarily have that detail on this panel. All right, so I just wanted to know if you had any questions on that. Questions on the submittal? Do you understand the submittal? Do you understand the four type of points? Joe, you're sitting in the back. What are the four type of points you got?
And I input.
AO.
Or, yeah, I don't remember all of them.
Oh boy. All right. Phil, you know them, right?
Yeah,
What are they?
analog input, output, digital input, output.
There you go. Look at that.
That made a candy bar
That's it.
or a cup of Joe.
How about the donuts?
The donuts, yeah.
Yeah.
We're waiting on the donuts.
Hostile,
Yeah,
see?
Coupon went
That's
bad.
it.
They're very hostile. You gotta get donuts.
I know.
Went bad.
You got to feed the animals in the cage. Is that what you're saying?
I didn't say that.
So you guys good? Because then
That box with VMA.
VMA, right? All right. I had mentioned that before. That's a controller inside the VAV box. I mean, we're not doing it for this, but I'll go over it now anyway. VMA. All right. Basically, in a VAV box, all there is a little shaft, right? And it controls a damper, right? And then the other device you have is a ring, a cross. That's an airflow station. So you have an airflow station, and you have your damper. And that just comes in a big box, and we call it a VAV box. What we slap on this shaft, it's a damper motor and a controller. It's got the brains of the FEC. So we wire power to that and network. So here's your power, 24 volts, and there's your network cable, so we could see it on there. This controls the airflow in the box. So you have a temperature sensor in the room, that gets wired to here. Then you also have, here's your ductwork, and then you have a temperature sensor here to monitor this, and then you're gonna have a coil with a valve. So this VMA is in there, and it controls your room temperature, controls the valve, it monitors airflow, controls your airflow out, and monitors the damper. So we're going to get to that when we do the VAV boxes. You climb up a ladder, we'll show you with the VMA and everything that goes inside there. I don't, do you have any existing in this building? Yeah. So you already have these are existing in this building.
Yeah, but due to the age difference in them, this building and that building, are they gonna be the same program? Does the old ones have to be updated?
No, they're the same.
Software is gonna be, everything's gonna be the same?
Yep. Yeah, that's one thing that really doesn't change that much. I mean, the only reason why we update these is if the front end can't see them, and then you flash them so they're kind of, but the software knows is same generic software. It hasn't changed in I don't know how long. So if you guys are all right, if you have any more questions, I'll give you any more questions, more answers or Q&A, or we can go upstairs and I'd like to go over the graphics though. If you have the graphics sheet, I just give you, because once we're in front of the graphics, can you throw me one copy? Just so I'm on the same page as you, no pun intended. All right, so the graphics now, when you're gonna come log on to the graphics, you're gonna get, I think Nick made it that it's your first name, last initial is your log on. Your password is gonna be SBPC 1234. After you log on the first time, it's gonna ask you to change your password. So then you'll all have an individual log on that no one knows. So what's gonna happen is, if you look at this, you're going to click onto login, and this should be your home page, which is a picture of the NRB and the CSB. And you'll be able, once you do that, to pick the building you want, click on it. And then, so in this case, we said the CSB. So the next graphic is this old CSB homepage with all the links on it. All right, so then I said, okay, if you wanted to see the chiller plant. So the next graphic will show you the chiller plant. So there's now 3 chillers on there.
But it's a new graphic already, it's not.
Yeah, this is the new graphic. So then you'll see the chiller plant here. And what I was telling you about hardwired points, set points, and everything is on the top right-hand side. There's 2 pop-down menus. So that will tell you the set points. So you should not have to change the set points. The only time you change the set points, like I said, if you wanted to change the chill water temperature, that's really the only time you should be changing the set points, because eventually a balancer comes in. The balancer comes in and tells me those numbers. So I put those numbers like for differential pressure set point. The balancer is going to tell me that's the number. You know, the only reason why you would change that number is if you have clogged piping, you have a problem, and you want to lower the number, that'll lower the pumps down. You raise the number, you're going to raise the pumps, and you're going to raise the pressure in the system. So it all depends on, you know, if you have an emergency and you want to do something. One thing is, if a VFD fails and it ramps up to 100%, well, that DP, it's not reading, maybe it's not reading DP. DP says 0. So all your pumps keep coming on and it ramp to 100%. First thing you're going to look at is your DP transmitter, right? So if you look here on the graphic for the pumps, in the middle all the way to the right, there's your DP transmitter, right? If that thing fails and reads 0, right here, if that thing fails and reads 0, that's your control point. The VFDs are going to fly up to 100% to maintain whatever the DP was. So you may just want to change the set point. Put on here, on where it says DP set point, instead of making it whatever, you can make it 0, or you can falsify the DP, or go to the pumps, put it in hand at 50%, right, which would be 30 hertz. Then you know you have enough water flow, at least temporarily, till you can fix it, replace it, or whatever you have to do. All right, so if you were there and you got that information, the next slide is your future pump room. There's a heat exchanger down in a pump room by your guy's office. So that's all the information there. And again, we're going to have a training class separately just on that room. But if you click on that, we're going to teach you how to go forward and backwards through the screens. There's 2 ways of doing that, and that's put here. You can use the back arrow, or when you're on a certain screen, there's tabs to go to another one. So you don't have to keep clicking back. So if you're in a condenser water system, you can click chilled water system. There's a button there. And I want all you guys to play with the graphics, because if you feel comfortable with the graphics, you can get a lot of information there. Plus, if you have a problem and you can go to the right graphic, take a picture with your phone and send it to us, we can help diagnose what the issue is. All right. The next page, you got the condenser water system. Right, and again, we're going to go through the graphic. You'll be able to understand what to click on, what not to click on. And then you could also wind up going back to the home screen. So the last slide is your future NRB screen with the floor plans and a brief summary. So that's how the whole thing is going to start coming together. I mean, we don't have all the graphics yet, but for the chiller plant, they're all done, and you guys can play, and we encourage you to play while we're here. So if you have a problem, we can ask a question. You guys good? I think we should go upstairs and play with the chiller.
Double click or drag, doesn't matter.
How old BMS? We're still using or we're not using that anymore at least?
Not using it. You
Not-
don't need it. The third chiller is
I
not
mean,
on there.
but it's still there, right? We
So,
just
but
don't
we're
touch
gonna delete
that.
it.
Okay.
No, we need it because I don't see secondary pumps for
You see the secondary pumps.
building. Okay.
Go up to the top, enables to the system, toggle that to true.
And he's an expert.
Dimitri knows.
I did it many times.
It's going to do that automatically. No.
How can we see
I don't know.
secondary pumps in building?
Put 1 and 2 in maintenance mode.
Ah. No, this is
I got
for,
you. And then you go right here.
for building 8-9.
No, this isn't linked yet. The towers.
So now what we want you to do is, you'll see the green part of the chiller turn to blue when the chiller's on. When the chiller actually comes on. But you'll see which valves are open. So chiller number 1 is your chiller. So click on the pop down right next to the chiller. There's a pop down. And that'll give you, and then you can open that up, and that'll give you all the chiller info. No, you don't have to scroll down. You can open it up, make it bigger.
Yeah, you could expand it.
Go down to the bottom line. Right
Press
there.
the
Now drag that down.
Yep.
Now all your information on the chiller's there, so you just watch the full load amps start going up as the chiller loads. Can you open up the VFD and tell me if you have any individual points on the VFD? There you go. Look at that, he's got it. He's a pro. So that's all, you know what I told you about software points from the drive? That's all the points available. So if someone wanted to do power calculations or how much you're doing in the building,
But we're not changing those points, right? We just
No.
see it and it is.
Yeah,
and
you
it-
ju- you
this
can
is
just see it.
It's just information.
correct. That's correct. So then hit the back button. There you go. So now you know if it's an alarm, it could tell you the alarm number on that page, so you don't have to actually go to the drive.
If it's here alarm,
But you could see it's alarm if it's an alarm or not.
yes, now it's a normal, but again, if it was alarm, right? And
Right.
go here,
It'll tell you the
we will
alarm.
see where is it, right?
Anybody
Yeah.
wants to change their username?
But the thing is that you should, when it has alarm there, you should actually check it in the field.
Because you have
You know what I mean?
No, it's okay, it's fine. It will be, at least we know why is that alarm.
Right. Now you can go over, see where it says commands and status on the top.
One or two other people
Yes.
besides
And
myself.
no, on the right, all the way right there. Now open up that window more. Right? So that'll tell you when it says chiller rotate.
They
So
can't
right
touch
now,
any
if
points,
we
but
hit
you can
that,
do
it
anything
made
on
it true. Don't do it.
Yes, it's
Right?
gonna-
Number 2 will come on. Here's the panel. Here's the panel layout. This is an existing panel, but I wanted to show you what an NCE is, and these are the IOMs. The difference in this, one's bigger than the other one. This just has more IO count. Right?
What?
IO, remember input output?
Yes, yes, yes.
All right, this just has more inputs and outputs than the other one.
Ports, right?
So when we only need a couple of ports, we have smaller ones and we have bigger ones. So remember, this communicates, right, to these. This wire goes from here to here to here and gets all the information.
Through the SA bus.
Yes. This is a Cat5 cable that goes to the network switch, which is in here, which links the computer. So these are all the big, remember I told you the big ones? These are the big ones? The big ones all communicate on Cat5, right? And this is the SA bus, which links this to that.
You said that one has a 5,000 point limit?
Yeah, well, yes, 5,000 points.
NCE, right?
Right, NCE and the NAE, which is in that panel. So it's 5,000 points or 99 per loop. And remember, the difference between the NAE and the NCE, this has one loop, the NAE has 2 loops. So when you're getting to the new building, they'll all be NAEs because we need those loops to get all those 485 VAV boxes in. All right?
All right, so this one has, what, we have 3 IOMs, an FEC on the bottom. I don't know what really the purpose of that is, besides for probably memory and...
That's it, it's just memory.
But as you can see, you got all your wires labeled. So on the bottom here, you got labeled to what terminal it goes to on your terminal strip. And then on your terminal strip side, you have what input or output it goes to on the actual controller itself. Obviously, you got your transformer up here, resets on there, another transformer here with a reset as well. This is your rectifier. This is what we're using for our DC power. So anything like with a 4 to 20 milliamp signal be coming off of this. So for any reason any of your temperature sensors or anything like that go out, you want to check to make sure that this is good or this fuse isn't blown. Because that's a lot of times when you see multiple temperature sensors go out, it's because your rectifier went bad or a fuse blown. Other than that, you got your relays down here, which I think are being used for the valves up on the cooling towers. And those are just to trigger the 110.
The relay label? Which one?
The relays are labeled by number. The numbers you can reference on the actual drawings themselves.
You want to open up the other one? You want to go into the batteries, the controllers?
Oh, the batteries?
Yeah.
Well, these don't have batteries. These don't have batteries. The NC has a battery.
Is
They're
there
really-
any case where
nothing
there
really-
will possibly, it sounds like a dumb question, where it'll be a point overload for the NCE?
As far as an overload, what do you mean by overload? Like they're not ran out of points?
Yeah, that it
Or
ran
when-
out,
when
that it
you-
doesn't have no, it has
Oh,
no
it has no space for, say, a particular point. Like you got your BOs and your AOs
Yeah,
and your...
and then all of a sudden it just, somehow, some way, it feels like it's picking up more points. And there's
No, because
space
you
for
have to define where your points go on the list.
Okay.
So if, say you have a BO, but there's no BOs available, you could use a CO. But if a CO is not available, then you're gonna have to add another controller,
Okay,
which would be an IOM.
yeah, all right.
But you have to add those in the list actually in software in the CCT program. You can't do that from the head end.
Okay,
One
good.
of the things
So-
I was saying downstairs was you could add up to 7 IOMs to one control. And the reason for is you limit out the memory and the speed of the controller if you went past that. You know, you bog the whole system down.
And as far as these, well, on the NC you got these lights. The fault light, when you see a flashing fault light, it could be a bunch of different things. It could be internal board temp. It could be you're near the capacity of the memory in there. There's a couple different
Just on
things.
that box itself, right?
Just on this box itself,
this
yeah.
box
But there's
Oh, on
no
this
way
system,
for
yeah.
us to know that. We would have to.
You could go through the, you could go through the head ends, and it'll give you kind of like a breakdown, like a diagnostic on it.
Okay.
But you're not going to know what the limits are unless you look at the actual literature.
Okay.
So,
But that's.
but we
not-
could get you. I could get you that. That's not a
Is
problem.
that something that we're supposed to?
No, that's something more along the lines of a service
That's more
service
you go in
contract.
there and
But I'm just saying, don't get nervous if you see a fault. It doesn't really, unless you see a solid red light, it means you probably dumped your memory and you have no program in there at all.
Actually, if it's a dump and not flashing, it's a problem.
If it's a flashing, it's a it's more like an alarm. If it's solid, it means you probably dumped your memory and that the thing's not functioning.
Actually, that box itself, on this moment, it's not working, right?
Yeah,
If
we'll be
it's
getting
not
question
flashing,
marks
then-
on
Yeah,
everything.
if it's solid red,
Yes, it's
then
not
it's
working.
not working at all.
If you have an issue with the battery on these, they tell you. I don't know, they don't tell you on these, but on there's no battery in this actually. But this one, it'll tell you if there's a battery fault, and then your battery's under here.
And they suggest every 3 years you replace the battery.
And then this is just your connectivity lights, what speed you're running at, and what speed you're running at, making sure you got your Ethernet blinking, means you got connectivity.
Burned in memory. So things like certain programs, certain things, what address am I and everything are burned in the EEPROM. That battery keeps the EEPROM, so when you lose power, it helps keep that memory. Like right now, if you pulled the battery out, it wouldn't do anything only because you're a live power.
Yeah. That's why, like, if say you had to reset, this like went into a fault, and you tried to do a reset, and you shut the power, it's gonna stay on. You're gonna have to pull the battery and put the battery back in. See how it's almost the, if you look, even look at the lights on there. They're the identical, the same lights, but you have two blue connectors, which means 2 different trunks, which means you can put a lot more devices on this.
Right, so if each one of these can hold 99, right, this one can only hold 99. That's the
This
difference.
one connected for that one, right? From this one.
Yes, via the network switch.
Yes, this one.
Whenever you see a cat cable, it's always going to come back to a network switch, back to the computer.
One of these, which is from 2 of this one, which is the main one, which is
There is no real main one. They
no
all,
boss,
so what they
no boss
do,
between 2 of them, right?
right, so what they do is on the network, each one has an address. Address 1, address 2, address 3. And it keeps pulling through each one. And what they do is the speed at which they do that is called the baud rate. Okay? The baud rate, I think, is 32.9, 32,900 kilobits per second. 32.8. So that's the speed at which that bus goes around.
We really don't care about the baud rate.
Yeah, I was just saying, but it's a trivial number,
Yeah.
but that's what it is. So we wanted to show you how these interact with that, and on that drawing you have, you're gonna get that exact drawing is your drawing in the submittal. And when we go out to the panel, like what we were saying, how this is the cooling tower, this was existing. We needed more memory, so we added this panel. The chiller plant, we're gonna go outside and we're gonna show you how we had to add from these IOMs, this communication cable, see how there's 2 of each? Goes out to the panel outside to the chiller
It's the
plant.
same concept of what the cooling tower is doing.